The root system plays a key role in crop performance, particularly through water and nutrient uptake. An efficient root system allows plants to tolerate challenging climatic events, such as drought or excess water. Its study is, by definition, more complicated than that of the aerial parts of plants, since it takes place underground. As part of the Root 2 RES project, funded by the European Union, we are evaluating different techniques for characterizing plant root systems. Shovelomic sampling is the most widespread technique. It allows access to plant root systems directly in the field using only a shovel. This technique involves collecting samples from the surface soil, the top 25 centimeters, and characterizing the three-dimensional architecture of the main roots. In the case of straw cereals, we collect a sample of 5 to 10 plants from the same row in a representative area of the plot. These samples are then labeled and taken to the laboratory for a cleaning step. The goal of this step is to make the plant roots clearly visible. They are then ready for root system characterization. In order to characterize the plants, a number of traits are measured. The simplified method involves noting the number of stems per plant to estimate tillering density, the height of the white section on the stem, which gives access to the depth of the underground part of the plant, the maximum width between the nodal roots, the depth at which this maximum width is found, the root angle of the nodal roots, the length of the nodal roots forming this maximum angle, and the maximum length of the root system. Once the characterization is complete, the root system could be scanned with the WinReso software, which extracts the length and diameter of all roots from the image. Measuring root and above-ground biomass allows for the calculation of the root-to-shoot ratio. Shovelomic sampling is a relatively simple method, since it requires little equipment and can be carried out regardless of soil type. As part of the Root 2 RES project, these measurements are performed at the start of stem elongation stage, when nodal roots are well developed. We have deployed this method at key sites, representative of the 3 main agroclimatic zones in Europe, on spring barley and durum wheat trials. The results from the first year of experimentation allowed us to identify the most important traits for characterizing spring barley or durum wheat roots and to adapt the protocol for use on a large number of plots. At Arvalis, these tests were carried out on the PhenoField platform, which makes it possible to expose varieties to different water stresses using mobile shelters and phenotyping sensors with gantry or phenomobile in Gréoux-les-Bains, southeast of France. The ambition of the Root 2 RES project is to provide a set of tools for geneticists, breeders, and agronomists to improve the study and valorization of key root traits. The ultimate goal is to enhance crop resilience to the suite of stresses associated with climate change.